In this example, we're going to use logarithmic differentiation to go ahead and find the derivative of this function here. And you'll notice we have an x in two places, one in the base and one also in the exponent. So if you'd like to, go ahead and pause the video, give this a try, and then come on back and we'll work it together. Okay, so the beauty of using logarithmic differentiation is that we can take something that appears complicated with x's in the base and the exponent, and we can rewrite this as something not quite as complicated at all. So let's go ahead and start by taking the natural log of both sides of this equation. And so that's what this will look like. Well, this is so nice because now we can use the properties of log to rewrite this right side just a little bit. So this exponent can also be brought out front and used as a coefficient here and multiply these together. So it looks like the natural log of y equals the square root of x times the natural log of x. And this isn't so bad at all because now it turns this right side into just the product rule. Here we have the first and here we have the second. Okay, I've also included here this derivative rule, so it's the derivative of the natural log of u, and that derivative rule states that that'll be u prime over u. And this is just one of many derivative rules that you can find typically in the front cover of your calculus book. Okay, so the derivative of the ln of y is going to be y prime over y, and that will equal now, and let's use our product rule. So the derivative of the first, so that'll be 1 over twice the square root of x times the second, plus the first times the derivative of the second, and the derivative of the natural log of x is just 1 over x. Okay, so this is what we have right here, and let's clean that right side up just a little bit. It looks like this expression right here, or this term, part of the expression, can be rewritten as the square root of x over x, which if we were to simplify that, you could say that's 1 over the square root of x by factoring out and canceling a square root of x from both. And we might consider doing that because our denominator will have the square root of x, which this denominator has the square root of x, so it might be a little easier to do that. So let's see what that might look like. So this first term, we have the natural log of x over twice the square root of x, and to that we're going to add 1 over the square root of x. Well, if we multiply this second term by 2 over 2, we get common denominators. So we'd have the natural log of x plus 2 all over twice the square root of x. And that's not bad at all. Okay, but remember, we're trying to solve for y prime, or dy dx, and right now that's being divided by y. So let's go ahead and multiply both sides by y in an effort to go ahead and isolate that y prime. Okay, but remember, what was the y to begin with? Well, it was x to the power of the square root of x. So let's go ahead and exchange that with x to the power of the square root of x. And we're multiplying that now by both of those terms. So you could leave it separate or you could distribute it through. I'm going to show you something here that we could do that I think is interesting. So what we have here is x to the power of the square root of x, and that's going to be over twice the square root of x times, I'm just going to go ahead and bring that 2 out front instead and change the order and say 2 plus the ln of x, just so there's no confusion as to whether this is the natural log of x plus 2 or whether it's the natural log of x plus 2. Okay, that kind of thing. Okay, so you could leave it just like this, and everyone would be very happy, and this would be a nice derivative. I want to show you, though, something you might consider doing to maybe clean this up a little bit, or maybe not at all. Okay, so this, you'll notice the base here is x, and we could rewrite this, the square root of x, as x to the 1/2 power. So what I'll really have for that first term is x to the power of the square root of x over twice x to the 1/2 power. These like bases, I could subtract the exponents, so I would have 1/2, and that's that 2 right there, times x to the power of the square root of x minus 1/2 by bringing this 1/2 up. And again, this might not look any better. It definitely looks kind of like oof right there, but just something you can do or could consider doing using those power exponent rules there. But anyway, so here would be the derivative of this initial equation, and we found it by using logarithmic differentiation.